Now we are up and running. Questions from 2.5. Once again, sorry about the delay, everybody. I had to completely restart my machine, and it took me on about 15 minutes to get everything up and running again. Five questions out there. Now I am frozen. Kirsten, okay, I'm sorry. One more time, somebody else out there, am I frozen to you too?
You are not frozen.
All right, thank you. I'm getting all these bad messages on the chat, and I just wanted to double check. All right, well, one more time. Any questions from 2.5 as I'm going to begin the new part? Kirsten, I'm sorry, I'm frozen for you. I don't know what to say. I think it might be on your end this time. Then I'm going to start the new section. Yeah. Okay. I sound like a robot and I'm frozen. Well, okay. So this is lesson 2.6, combinations of functions, and there are several ways to combine functions, as you can tell from the learning objectives. At the learning objectives on the bottom, we're going to add, subtract, multiply, and divide separate functions. We're going to compose them to solve problems. So we'll dive right in. So for my examples today, I have just randomly picked two functions. I'm going to hang on, I'm just going to take my keyboard off here so I can access my writing tool a little bit better. So the two functions I have picked, you should be able to see up here in the corner. F of x I've just said is 2x minus 5. G of x is 4x plus 1. Now I'll admit these are a little bit on the simplistic side because they're both what? Good old linear equation, but that's okay. To get started, that's what we want to do. First thing we want to do up here is we want to add two functions. And by the way, this is the notation that is the shortcut notation for f of x plus g of x. I don't leave it to mathematicians. They always have to have a shortcut to do things. Kirsten, I hope I'm still not frozen for you, and I still hope I'm not scaring you with my rough voice. But anyway, let's continue here. G of x is the shortcut way to say what's over here on the left. But anyway, either one of them, it's as simple as can be. All you have is just good old algebra rules, add like terms, and I mean, there's nothing to it. 6x minus 4. So that's simple. The second thing, subtraction, is also quite simple. Again, all I got to do is remember to what? Pass on my negative, my subtraction sign. Make sure you put the second quantity in parentheses so that you distribute the minus sign. Here's the one that everybody seems to forget right there. That minus sign carries over. Anyway, then it's easy. Just combine the like terms. Okay? Any comment, question? Hopefully you guys are able to hear me, see my screen at least. All right, let's go to the second example. The same two sample functions, and this time, now we're on our third thing. This time we want a multiply function. Times g of x, shortcut notation, f times g of x, which you will see in the book. Well, this is not hard either. You guys know how to multiply things, so you multiply. Of course, you have to do your handshaking, and you're going to wind up with actually 4 terms, right? the old handshaking, two people shaking hands with two people, you've got four handshakes. They're your like terms. There's nothing unusual there either. And finally, the fourth what operation is, how do you divide functions? F of x divided by g of x. Well, you just put one over the other in fraction form. Here, there isn't a whole lot we can do, is there? I mean, we've got, because of the addition and subtraction on the top and bottom, so we can't actually calculate anything. However, do you notice I did make this statement over here? We should recognize properly, hey, there's no way that denominator can equal 0 whenever x is negative 1/4. So it's important that we at least state that x cannot be negative 1/4, because that would create a 0 over here in the denominator, and of course then division, we don't have anything. So just to recap real quickly, we just picking two sample functions, we can add them, subtract them. Third, we can multiply them, and fourth, we can divide. So the good old four operations that four arithmetic operations. There's more to this than that. But are there any questions or comments so far? I have a feeling lost. I'm going to just hang on just a second. I'm going to turn it on just to see. Yeah, no Kirsten. Okay. Unfortunately, I hope she can rejoin. All right.
Everything's fine on this end.
That's good. Thanks for the check. Okay, let's move on. I'm taking the same two functions, and this is the first time we are going to compose. Yeah, sorry that handwriting turned out pretty bad, but I didn't want to lean on the screen. Anyway, we're trying to compose two functions this time. So here's how we can write that. I personally like this notation, which we say f of g of x. So in other words, substitute function g in f. This is the way the book does that. Nuts about that notation, because it's literally a little circle in between the f and the g that's read f compose g. It's kind of foggy to me. Yeah, it was supposed to be a little bit of humor there, but it also, I mean, it's just not clear. Little multiplication symbol with a circle. So you're going to see me when I do quizzes and tests, I'm going to write my functions like over there on the left with a rectangle, okay? But you're going to see those little. All right. So now I'm plugging into function f. So this is my main function up here on the top. That's the main function. And in for x, on that f of x function, I'm going to plug in what g of x is, 4x plus 1. So do you see how I into the f function? And then, of course, from there on in, it's not very hard. And notice the parentheses are very important, because you have to take 2 times all of whatever you're plugging in and then subtract 5. So, I mean, from there on in, that's pretty simple, and you come up with a final result. Is 3. When you compose reverse, bottom here, we are now doing g of f of x. So this time, I'm plugging into function g, which says take whatever I give you, multiply it by 4, and add 1. And what are we plugging in? The 2x minus 5 from function f. And you notice I don't get the same answer. And that's actually correct. Composition of functions is not commutative. This is different from we're so used to multiplication and addition order. Well, you can't do composing in either order. As you can clearly see here, we do not get the same result. Pause. Question? You see what compose? So it's just basically a big fat substitution, and you got to remember the thing on the outside, f of g of x, that f is the main function. That's what we're plugging. And on the bottom one, g is the main function, and we're plugging f into that. So you got to really get your head on straight when you do these. Now, we just did a really pretty simple, and it's a little bit more complex. Now, please, I'm going to suggest you can do what you want, but you don't have to write this whole thing down. Rather, observe what's going on here. Okay, so now I just took two functions that are a little bit more complicated up there on the top. This time, function f is x squared plus 3x plus 1, and I'm calling function g x cubed minus 9. What I do is do f of g of x, and then I want to do g of f of x. Messier, as you can see. So now, in this first example, right over here on the left, main function is f, and I'm plugging g into that. So function f says, take whatever I give you, square it, then add 3 times that, and then plus 1. To g of x, every time there's an x, I got to plug in an x cubed minus 9. And twice. Because we had an x here, and we had an x here. So I had to plug it in 2 times. Well, as you can see, that's a little messy because you've got 9 squared. You got to multiply x cubed minus 9, parentheses, times parentheses, x cubed minus 9. Well, that results in this long thing underneath here. And then, I guess it's not that long. And then I got to multiply 3 times this, and that comes. Anyway, you put it all together, join the like terms, and there's f of g of x in this particular situation. All right. Now, let's do g of f of x. I've already warned you that they shouldn't come out the same. This one's a little uglier because now f into g, and I know you can't see them anymore. They're up there on the top. So this time my main function is x cubed minus 9, and for every x I have to plug in x squared plus 3x plus 1. X squared plus 3x plus 1 cubed minus 9. Well, that's a lot of multiplying. Just take it for granted. I put it all together. And do you at least, so here's the answer way down here on the bottom. That big long polynomial. Notice that's not the same as this answer up on the top when we did f of g of x. So again, please note, composing functions is different when you do it in the opposite order. You get the same answer. Actually, you'll see tomorrow that there is a time when they do come out the same, but it's a very special situation when that happens. Get a different answer. So again, I didn't expect you to write all that down, but did you get the general idea that when you compose f of g of x, you have to plug g into f, and when you do g of f of x, you have to plug f into g, the same. Question or comment?
I have a question.
Yeah, go ahead.
Is it possible that something will ever be nested more than once, like g of f of e of x?
Yes. But
okay.
Hang on, we haven't gotten used to this yet. But yeah, that can happen. We're not going to much more than, well, you'll see. When we get toward the end of this, I'm going to do a little bit I'm going to do a little deeper nesting, but it's not going to be a long problem like this one. All I was trying to demonstrate to you here is that none, and that it doesn't work in reverse.
Okay, thank you.
Yeah, so maybe that'll clear up. In fact, here it is. I forgot it was coming this quick. So here's what I want you to look at here. Do you see that? Just take a look at this expression that I'm underlining in red. Okay, the cube root of the quantity x minus 2 squared. So what we're doing here is that's already a composite function. Three things going on there, aren't there? I mean, at the very inside, aren't you taking from x? That's your first function. Then you're taking that answer and you're squaring it. That's your second function. And then after all of that is done, you're taking the cube root. So in a way, this is a double composed. Think of it, look at the bottom here. I'm saying, all right, the first function is take what I give you and subtract 2. The second function is take whatever we got for an answer and square it. And the third function is take all of that and take the cube root of it. So here's really what? Kind of the three things that are going on there. And this is how you could write that as a composite function. Do f first, subtract 2, then do g, square that, and then do h, cube root it. So, Brandon, here's the answer to your, here's a double composed function. But I mean, it's you don't have to worry about, maybe you were thinking, am I going to have an army to help me do all the complex calculations? No, it's more of a, that sometimes a function has more than more than 2 operations. So here we have one with 3. And what would you start with? You have to first subtract 2, the f function. Then you have to square it. So anyway, so this is kind of the answer to your question, Brandon, but it's not going to be a marathon problem. You see what I mean?
Right, and you always start with the inner one.
You have some problems like this in the assignment where they'll give you a function and say, can you show me, can you show that as a composed function? And you might have to do something like we did on this page.
Okay.
So, yes, go ahead. Well, I thought you had another question.
Oh, no, I'm good. Thank you.
Now, one other thing we want to talk about. If we take, here's a relatively simple function, f of x equals x squared plus 1. A function with itself, and actually you can. In the book, they might write it like this, f compose f. But really, this is how I would write it, f of x. So in other words, can you plug a function into itself? And you can if you concentrate. I mean, what does this function say? It says, take whatever I give you, square it, and add 1, right? Take whatever I give you, square it, and add 1. All right. Do all of f. Take what I give you, square it, and add 1. So do you see how I composed a function with itself? I plugged a function right into itself. And you can work that out. You can take x squared plus 1 times x squared plus 1, which comes out, and then add 1. You can actually compose a function with it. That's a little bit hard to see for some people. I think if you just, maybe it came off better to you guys. By the way, some books will write that like this. I have crossed it out. It's like F2. I don't like that notation because I'm not sure it's clear, but instead of writing f of x, they will write F2 like an exponent. So don't think the book uses that, but you will see some books that use it. I'm not real nuts about it. I'm not sure everybody gets what's going on there. It almost looks like you're supposed to square F, and that's not what's happening here. it's composing. So composing a function with itself actually can be done, and I think you're going to see one or two of those maybe in the assignment. So let's take a look at some of the problems now. Now, we've got a variety of things going on here. If you have your book handy, we are looking at of number 1 on page 234. Okay? In the book, they've got function f, which is my black one up there. G black is my blue one. And then they're saying to you, can you add them up? And that's the red one. Now, this is not as hard as it looks. Might be looking mixed up to you, but if you take blue and the black, how high is the black point on this first black point right here? How high is the blue point? It's at -1. What's 2 plus -1? Oh, there's my red point. Look at this next notch. How high is this point right here? Yeah, I don't know if you can see my cursor. How high is that point right there? That's at 3. How high is this blue point down here? At 0. What's 3 plus 0? Point. Over here, the black point is at 1. About at 1/2. What's 1 plus 1/2? And the last, the height of f is 2, the height of g is 0, and 2 plus 0 is 2. So you wound up with these 4 new red points, which you can connect. And there's your red now. What do we have? This is f plus g. Actually, graphically, add the two functions. All right. Here's another one of those. This is number 2. And again, the book gives you F and G. They give you the black and the blue. Well, they're not black and blue in the book, but I had to color code them so you wouldn't get mixed up. Add them together. So again, if you add the black height to the blue height, you would get those red points that I've made there, and then you connect them, and that little red, call it a bunch of connected segments, that red one is the result when you add them together. So you know the old deal, when you add a negative to a positive, you actually wind up between, right? Whereas on the end here, you're adding up 1 to a 2, and you get a 3. So there we went up above. So anyway, just a kind of a quick review of simple addition. Do that graphically. The next one I wanted to look at was number 6. Okay, number 6, they give you two functions, function f and function g in the book, top here. And then they say, hey, we got all kinds of things for you to do. In part A, add them together. In part B, subtract them. In part multiply them, and in part D, which you can't see right now, in part D, divide them. So that's just practice what we did at the beginning of our session today. Those are pretty simple. And in fact, in the division, you see how I can't do much again? 2x minus 5 by 2 minus x. Well, I really can't, but I can say 2 because of the domain problem we would have down there in the denominator. Okay, so that's I believe that's pretty straightforward. Over to number 18. Number 18. So what does directions say? Evaluate the indicated function for if f of x is, I've got it up in the box up there in the top right corner. F of x is x squared plus 1, and g of x is x minus 4. Okay, then here's what they ask you to do. G, of t minus 2. Whoa. First of all, what's f plus g of x? That's taking these two guys in the box and adding them together. Well, that's simple. X squared plus x minus 3. Okay, now that I've figured out what f plus g of x is, now what's f plus g of t minus 2? So now plug in a t minus 2 up here wherever there's an x. Here, I plugged in a t minus 2 for x. And then, of course, you got a little bit of hammering, a little bit of, you got to take t minus 2 times t minus 2. By the way, don't forget about your middle term, right? And then just gather the like terms. That's it. So what made this one hard is you're like, whoa, what is this? F plus g of t minus 2. Okay, well, first find f plus g of x. This is a very important first step right here. And once you've got that, all right, now plug in a t minus 2 wherever you have an x. And so each operation is actually pretty direct and simple, but come together. You've got to do them. You really need to do them separately, I believe. Let's take a look at another one. This is number 26. I'll read. Graph the functions f, g, and f plus g on the same set of coordinate axes. For number 26, I should f of x is 1/3 x. G of x is plus 4. That's what's given. So, well, you should recognize those as straight lines, right? I mean, you could think of 1/3 plus x as 1/3 x plus a 0, so it's in slope-intercept form. Has a slope, has a y-intercept of 0. See, it's the blue line here, 0, and its slope is 1/3. So for every 3 to the right, up 1. See how I got this next point here? Okay, so there's f of x. G of x has a slope of -1 and a y-intercept of 4. So y-intercept, this is the, I don't know, it's kind of like an orange line. There's the y-intercept up there at 4, and the slope is -1. So for every 1 to the right, then add them together. I want, again, just go point by point. Like, so my answer, by the way, I was mistake. The G is this crazy orange is my sum, so I apologize. So up here was the y-intercept, and for every 1 to the right, down 1, every 1 to the right, down 1. You can see that's the black line. All right, so let me just show you an example here. This is what? The height of the blue line at 2 is approximately what? 4ths, let's say. Black line at that point is 2. And what's 2 plus 3/4? 2 3/4. And that's a point on my line here. By the way, in the beginning, 0 plus 4 is 4. We have 1 plus 2. I'm sorry, 1 plus 1 is 2. So anyway, you just keep, be no surprise that when you add a line, you get a line. That orangish thing, that orangish line. I don't know if I went too fast, but let's see what kind of questions. While you're thinking, so it's every other odd. Stop after 57. So every other odd, don't go past 57. Questions? I'm going to turn the student pictures on. Okay, I still have my 3. Go ahead. Any questions?
No, I'm good.
Thanks, Damon.
I feel pretty good about it as well.
This is a lot
Eva?
easier.
It seems pretty straightforward to me.
Well, I'm glad to hear that, but do contact me. I know it always seems sweet, usually writer class, and then you go do your assignment and you're like, whoa, what is that? Don't cover everything. So anyway, don't be afraid to contact me. In the meantime, I'm going to be teaching another class at another school later today, but still, I watch my electronic contact stuff pretty closely.
It's just these assignments take forever. They're very tedious.
What are tedious?
The assignments,
Oh, you mean these problems?
yeah, especially like 2.5 was bad. There was a ton of graphing.
Yeah, and they take time. That's true, but I don't. But evidently, from the lack of questions, they weren't really
No,
all that.
They're not hard. They're just tedious.
Yeah, I would agree. There's some of that in there. That's a good point. Other discussion? Otherwise, I guess we'll go a little early. Sorry, we started late and get done early. That's kind of weird. I didn't know that was gonna happen.
That's my kind of class.
Yeah, maybe we ought to get into a pattern here.
I like that.
Maybe very kind of you. Well, guys, I'm going to hang it up. Thank you. I appreciate your attendance.
Thank you.
You're welcome.